Okay, I just wanted to make a short video talking about solids of revolution, and I got some kind of visualizations here to hopefully help you visualize what's happening when we take an area and spin it around an axis of revolution. So let's get started. This first one here is just a basic solid of revolution. This is my graph right here. Okay, so you've got the y and x axis function f of x and g of x, and what I want to do is take and rotate it around just the x-axis. So when I do that, I'm going to rotate. I'm going to rotate it around the x-axis. It's going to create something that looks like this. Now notice, as I'm going around the x-axis, I'm creating a washer. So if I wanted to know the volume of this solid, I have to know a couple things. I need to know the length here, right, or the depth of the washer. So we'll rotate all the way around, and notice that basically what I've got here is a washer, right? And I'm going to, in fact, take an infinite number of washers, infinitely thin. And so what I need to really know is the area of these circles. Okay, so I'm going to take the area of the big circle here and subtract out the area of the small circle, and that'll give me the area of the washer times the depth. But remember, we're letting these rectangles get infinitely small, so there's no rectangles in this one. So that then is just going to be the inside radius is g of x and the outside radius of f is f of x. And there seems to be kind of an issue with, well, the x-axis is great, that's fine, it's wonderful, I know how to do that, or the y-axis even is okay. But what happens if it's a different line? All right, well, let's go to an example like that where it's a different line. So let's suppose that I want to go around the line y equals -1. So I'm going to take this region here in pink and go around this line y equals -1. Well, what does that become? Well, if I go over here to, I think I can maybe even zoom in a little bit. I'm going to rotate around, whoa, y equals 1. Oh boy. Okay, y equals 1, let's see what happens. Zoom out here, and then we'll rotate this thing, and then I start to get this solid. And now this one isn't kind of labeled nicely like the other one, but if I spin it around, notice that the kind of the inside and outside radius here are just going to go from this red line out to the top function value, whatever that is, and then from the red line to the bottom function value, whatever that is. So we're still just worried about the radius of the washers. It's 1 unit longer than if it was the x-axis in this case. So we would just add that 1 to the function f or the function g, depending on if we were looking at the inside or outside radius. Lastly, I want to look at shells. So let's suppose that I want to get rid of this solid completely here. So I think I can do this. Let's kill it. Okay, so this is the curve that I want to rotate around the y-axis. All right, and let's give myself a couple more rectangles here. And I want to go around the y-axis. And so when I do that, it's going to look something like this. I can only get you half of it, but it's going to look like that, kind of like a bundt cake. And so when I do that, though, right now I've only got 4 cylinders, so it's not a very good estimation. Look at all this blank space in here that we're kind of missing, and then I've got an overlap here. But if I take this and make it, and I'll show you the cylinders too, that'd be good, and I make more and more cylinders, let me give you a better view, the more cylinders that I have, the more accurate this gets. In fact, I'm letting the width of the cylinder approach 0. I want those cylinders to be infinitely small, and so then really all I'm concerned about is the radius of the cylinders and the height of the cylinders, because I don't care about the depth anymore. That's going to, the integral is going to give me the volume of the solid. This is obviously only half of it, but that's going to give me the volume of the solid revolved around the y-axis. So hopefully that gives you a little bit of a visualization of what's happening here, and then it should look like, look like a solid. So hopefully that gives you a little visualization of washers and cylinders, and why they're kind of helpful, and how the integrals are set up.